Question number 4. Show that the given equations 5x plus 3y plus 7z equal to 4, 3x plus 26y plus 2z equal to 9, and 7x plus 2y plus 10z is equal to 5 are consistent and solved by rank method. Show that they are consistent. It should follow any one of the first two property. If it is consistent, you should have a solution. If solution exists, it will happen in two different way. One is a unique solution or an infinitely many solution. Now, the corresponding matrix equation is coefficient matrix, variable matrix, and equal to constant matrix. The coefficient matrix is 5, 3, 7, 3, 26, 2, and 7, 2, 10. The variable matrix is always taken as x, y, z. The constant matrix 4 in the first equation, 9 in the second equation, and 5 in the third equation. Now we have to form an augmented matrix. Augmented matrix AB is nothing but combination of matrix A and B. A is 5, 3, 7, 3, 26, 2, 7, 2, 10, and B is 4, 9, 5. This is augmented matrix AB. Now, we should form the given matrix as an equivalent matrix in the form of echelon or echelon form. For that, here the entry is 7. Here we have 5. Multiply the first row by 7 and the third row by 5. Subtract. You can easily get this entry as 0. That is a better way. Else, you should divide all the entries in the first row by 5. Then make this entry as 1. Again we multiply the first row by 7. You can subtract. That will be some lengthy process, because if fractions appears, then the further applications will be difficult. So just multiply R1 by 7, it will be 35. Then R3 by 5, this element has 45. Then we subtract 35 minus 35 becomes 0. So it is very easy to form another equivalent matrix. This R3 tends to, we are forming an equivalent matrix. In this R3 become 5R3. Multiply R3 by 5, it will be 35. And multiply R1 by 7, it is 35. Subtract these two. We can form a new row R3. For that, I am processing here 5R3, 35, 10, 50, 25. Multiplied R3 by 5. Then multiply R1 by 7, 35, 21, 35, 49, here 28. Subtracting first entry, 35 minus 35, 0. Now subtract. After subtracting we have 0, minus 11, 1, minus 3 as entries. So 0, write it in the third row, 0, minus 11, 1, minus 3. Now we should give priority to make this entry as 0 in the second row, first entry. For that, multiply first row by 3. This 3 with the first row, that is 15. And this 5 with the second row, that is 15. Now 15 minus 15 becomes 0. You need not to focus on any other element. Always focus the first element, okay? First element. R2, therefore, R2 tends to 5R2 minus 3R1 minus 3R1. Here the iteration happen here. I am processing here 5R2. 5R2 means multiply R2 by 5. 15, 26 into 5, 130. Then 2 with the 5, 10. 9 with the 5, 45. Next, multiply the first row by 3. That means 15, again 9, then 21, here 12. Subtract. 15 minus 15, 0. 130 minus 9, 121. 10 minus 21, minus 11. 45 minus 12, 33. Now we have 0, 121, minus 11, 33 as the answer. Write these entries in the second row. That is 0, 121, minus 11, 33. Then 5, 3, 7, 4. No change in the first row. You can keep the same as it is in the first matrix. Right. Now look at the last two rows. They are proportional. Multiply by minus 11. Minus 11 into minus 11, 121. 1 into minus 11, minus 11. Minus 3 into minus 11, 33. So these two are proportional. So we can reduce the second row by 3. Divide the second row by 3. It will be reduced. That will be equal to I am going to write here. The another equivalent matrix is 0, minus 11, 1, minus 3. There is no change in it. R2 tends to R2 divided by minus 11. R11. R2 divided by 11. Divide R2 by 11. 0 divided by 11, 0. 121 divided by 11, 11. And here minus 1. And here 3. The first row, no change. 5, 3, 7, 4. Now look at the rows. They are proportional. Just multiply by minus 1, you will get the third row. So just adding these two rows, all the entries in the last row will become 0. That means the next equivalent matrix is R3 tends to R3 plus R2. Adding these two and writing in R3, 0, 0, 0, 0. Now all the entries in the third row are 0. Now we are moving to form this 11 as 0. To make this 11 as 0, we should multiply this first row by 11 and the second row by 33 and we should subtract. Suppose doing that, this 0 entry become non-zero. So you can stop the process and this may be this indicating that the problem is getting over. So now write the second row as it is in the above matrix, then write the first row 5, 3, 7, 4. Now this is the required last equivalent matrix. The last equivalent matrix is in echelon form and also we cannot push it further. So we can stop the process here and we can conclude the answer. Now find the rank of A in the last equivalent matrix. The last equivalent matrix consists of only two non-zero rows. Therefore rank of A equal to 2 and rank of AB. Now adding the fourth column with the matrix and also finding the rank. Now here also one zero row and two non-zero rows which implies rank of AB is also 2. Here rank of A equal to rank of AB equal to 2. We can conclude the answer. Rank of A equal to rank of AB equal to 2. That is less than 3. That means less than 3. There are 3 unknowns x, y, z. The rank is 2. That is less than the unknowns. Number of unknowns. Less than 3. That means less than number of unknowns. Less than number of unknowns. Less than 3 it is enough, it seems. Less than 3. Therefore, the system is consistent and it has infinitely many solutions. Now, rank of A equal to 2, rank of AB equal to 2. Rank of A equal to rank of AB equal to 2 less than 3. That means less than number of unknowns. Therefore, the system of given equations is consistent and it has infinitely many solutions. To find these infinitely many solutions, we should convert the last equivalent matrix into matrix equation, that is 5, 3, 7, 0, 11, minus 1, 0, 0, 0 into the corresponding variable matrix x, y, z, that is equal to the constant matrix. This last column denotes the constant matrix 4, 3, 0. The last column denotes the constant matrix. Now framing the equation, forming equation from this matrix equation, we will get 5x plus 3y, 5 into x plus 3 into y plus 7 into z, plus 7 is z equal to 4. Let it be equation 1. And second one, 0x we can omit, 11y minus 1 is z equal to 3. Let it be equation number 2. The third one is 0x plus 0y plus 0z. No equation will be formed. Therefore, third equation will not be formed. By using these two equations, we should solve and find x, y, z values. We have two equations, but number of unknowns is 3. Whenever the number of unknowns is greater than the number of equations, the system of equations follows infinitely many solutions. We have two equations but 3 unknowns appears. In this case, we can have infinitely many solutions. Already we have discussed it is infinitely many solution. So how to find this infinitely many solution? In this case, there are infinite solutions. We should assume either for x or y for z a real number as a solution from the infinite numbers. Let to solve, assume z equal to k where k belongs to R. Assume one solution k as a solution from this equation to these equations that is taken from the real number, and substitute in the second equation. 2 implies 11y minus k equal to 3, then 11y equal to 3 plus k, which implies y equal to 3 plus k by 11. This is y value, and substituting the z equal to k and y equal to 3 plus k by 11 in the first equation, we will get the value of x in terms of k. Here look at the answers. Z in terms of k, y is also in terms of k. We can find x also in terms of k, which implies substitute z equal to k and y equal to 3 plus k by 11 in 1, which implies 5x plus 3 into y. Instead y substitute 3 plus k by 11 and plus 7z. 7 into z values k. 7k equal to 4. Multiply 3. Continued here. 5x plus 3 into 3 plus k by 11 plus 7k equal to 4. Multiply 3 inside. 9 plus 3k by 11 plus 7k equal to 4. Now bring these two terms right side. 4 minus 7k minus of 9 plus 3k by 11. Now bring minus inside. Minus 9 minus 3k. Taking LCM. 44 minus 77k minus 9 minus 3k whole divided by 11. Simplify this. We can get 5x is equal to 35 minus 80k by 11. Dividing by 5. This one become 1x or x. Here 7 minus 16k by 11. So x is equal to 7 minus 16k by 11. And the solution is, already we have found y and z. Now x is equal to 7 minus 16k by 11. Therefore, solution x comma y comma z equal to 7 minus 16k by 11, 3 plus k by 11, comma k, where k belongs to R. Question number 6, exercise 1.1. Given for what values of lambda the above system of equations fails to have a unique solution. The given system of equation 3x minus y plus lambda is equal to 1, 2x plus y plus z equal to 2, and x plus 2y minus lambda is equal to minus 1. In this equation there are two constants, they are unknown. The first equation lambda z is given, the coefficient of lambda is unknown, and also in the third equation coefficient of z is minus lambda is given, that is also unknown. So we should find the lambda value for which the system of equations fails to have unique solution. That means the system of equations can follow either infinitely many or no solution. Okay, in search of the answer, write the given system of equations in the matrix equation, then write in augmented matrix, augmented form. Augment means combination of this A and B, that is written here, then which is equivalent to. To proceed further, to make it easy, I can interchange row 1 and row 3, because if we keep 1 in the place, it is easy to calculate. So interchange of R1 or R3 takes place here, that is R1 interchange to R3. Now we are going to make these two entry as 0 first. To make this entry as 0, you can proceed R3 tends to R3 minus 3R1, because here we have 3, here we have 1, multiply it by 3 and subtract from R3. Subtract R3 minus 3R1. Happening this, we will have 0, minus 7, 4 lambda, 4. R3 minus 3R1. R3 means 3 minus 1 lambda 1. Then multiply R1 by 3. 3, 6 minus 3 lambda minus 3. Subtract minus plus plus plus. These two get cancelled, 0. Here we have now subtract 3 minus 3 0, minus 1 minus 6 minus 7, and lambda plus 3 lambda 4 lambda, 1 plus 3 4. So this is written in the last row. Making this 0, these things happen, and then return the final answer in the third row. For the second case, to make this 2 as 0, R2 tends to R2 minus 2R1, because we have 2 multiplied by 2, subtract, we will get this entry as 0, that is R2 minus 2R1. R2 minus 2R1. R2 means 2, 1, 1, 2, 2R1. 2, 4 minus 2 lambda minus 2, subtract. Here 0, minus 3, 1 plus 2 lambda, 4. that is written here. 0, minus 3, 1 plus 2 lambda, 4. Now our next move is to make this minus 7 as 0. For that, multiply R2 by 7, it will convert to 21, and then R3 by 3, it is also 21. Then we can subtract, we will get this entry as 0. For that purpose, this will follow 3R3 minus 7R2. 3R3 minus 7R2. So 3R3 means multiply R3 by 3, 0, 3R3 minus 7R2. Multiply R3 by 3, 0, minus 21, 12 lambda, 12. And then multiply R2 by 7, 0, minus 21, 7 plus 14 lambda, then 28. Subtract, minus plus, minus minus minus. Now 0, again this entry 0. Now 12 minus 14 lambda minus 2 lambda. Here we have minus 7, and minus 28 plus 16 plus 12 equal to minus 16. Okay, now you can write these four values in R3. 0, 0, minus 7 minus 2 lambda, minus 16, and there is no changes in R2 and R3. So we can write as it is in the above matrix. 0, minus 3, 1 plus 2 lambda, 4, 1, 2, minus lambda, minus 1. Look at the last equivalent matrix now. This is in the equivalent form. Okay, now we can proceed further in an easy way. Given that the system fails to have unique solution, what is the condition to follow unique solution? To follow unique solution, rank of A equal to rank of AB equal to equal number of unknowns. Equal to equal number of unknowns. That is, here we have 3 unknowns, so that should be equal to 3. To fails to have unique solution means it may follow either infinitely many or no solution. Suppose if 0 appears here, what will happen? The rank of A 0, 0, 0 means the rank of A. Here we are substituting 0. For when lambda equal to 0, when substitute lambda equal to 0, lambda equal to 0, or this entry becomes 0. If the entry becomes 0, the last row fully 0, so this is counted in the 0 row, and these two are non-zero rows. Okay, you need not worry about this element, you can keep these two elements. Okay, so these two rows are non-zero rows, so that means rank of A equal to 2 in this place. Then adding the fourth column, finding rank, these are all non-zero entries, then rank of AB is equal to 3. This means rank of A is not equal to rank of AB. Rank of A not equal to rank of AB. Rank of A 2, rank of AB 3. Rank of A is not equal to rank of AB. This means the system follows no solution. Okay, right, in this place. So we can take this entry as 0. It will not follow, it fails to follow unique solution. So that purpose I am choosing here. When minus 7 minus 2 lambda equal to 0, rank of A equal, which implies minus 7 equal to 2 lambda and lambda equal to minus 7 by 2. Rank of A is equal to, and time, rank of A equal to 2, rank of AB equal to 3. The system, therefore, system is inconsistent. System is inconsistent. It fails to have unique solution. It fails to have unique solution. Question number 7 in exercise 1.1. There are three business people. They are purchasing and selling three different commodities. One is X, another one is Y, third one is Z. Mr. Anand purchases 6 unit of Z and sells 2 unit of X and 3 unit of Y. Amar purchases 1 unit of Y and sells 3 unit of X and 2 unit of Z. And Amir purchases 1 unit of X and sells 3 unit of Y and 1 unit of Z. Now the given situation represents the equations here. In the first case, Anand earns 5,000 and Amma earns 2,000 and Amir earns 5,500. Then what are the rate? That means what are the values of X, Y, Z that we have to find? The given information is converted into this equations. When we purchase, our money will be subtracted. When we sell, the money will be added. This means 2 unit of X means 2X and 3 unit of Y means 3Y. They are all sold by the person Anand. That means these two quantity are in plus, and 6 unit of Z is purchased. That means we have to subtract it. Totally the value will be equal to 5,000. In the similar manner, for Amma it is 3X, selling means positive, and 1Y purchases means negative, and 2Z sells again, it means positive. Totally the amount will be equal to 2,000. For the third Amir, total 5,500. When purchases 1 unit, a unit means it is 1 unit, 1x, that is purchase means it is negative, and then for selling this is plus 3y and a plus 1z. Totally it will be equal to 5,500. Now we should solve by rank method, and we should find the values of x, y, z. The corresponding matrix equation is quotient matrix, variable matrix, constant matrix. Quotient matrix 2, 3, minus 6, 3, minus 1, 2, minus 1, 3, 1. Variable matrix x, y, z, and then the constants are 5,000, 2,000 and 5,500. Augmented matrix, this is the form of Ax is equal to B. So augmented matrix AB equal to A, we have 2, 3, minus 6 and 3, minus 1, 2, minus 1, 3, 1 into adding the constant matrix here, 5,000, 2,000, 5,500. This is equivalent to now I aim to make this entry as 0, this minus 1 in the last row. Minus 1 in the last row. We should make the last row entry as 0. Then my last row we have minus 1, 3, 1, 5,500. To make this last entry as 0, we should multiply this third row by, or you can just interchange R1 and R3 now. Interchange R1 and R3, because if we keep 1 in the first one as a first entry, it is easy to solve the problem. So the interchange of R1 and R3 happened here. Minus 1, 3, 1, 5,500. Then here 2, 3, minus 6, 5,000. Now no change in the second row. Keep as it is. Now we'll start here. The equivalent matrix AB equal to minus 1 3 1 5500, 3 minus 1 2 2000, 2 3 minus 6 5000 after interchanging R1 and R3. Here, to make this entry as 0, multiply first row by 2 and add, because we have minus in here, 2 minus 2 becomes 0. So multiply R1 by 2 and subtract from R3. That is R3 plus 2R1. R3 means 2 3 minus 6 5000 and 2R1. 2R1 means minus 2 6 2 11,000. Subtract, just add, these two values will be added because we have opposite sign. So this is 0, here 9, here minus 4, here 16,000. So I have written here 0, 9 minus 4, 16,000. And then the next iteration, R2 tends to, I'm going to make this 3 as 0. For that multiply R1 by 3 and add. So R2 tends to R2 plus 3R1. So R2 plus 3R1. R2 we have 3 minus 1 2 2000 and multiply R1 by 3 minus 3 9 3 then 16,500. Here just add 0 and 8 then 5, here 18,500. Right in the second row, 0 8 5 18,500. Now our next move is to make this 9 as 0. For that purpose, multiply this row by 9 and R2 by 9 and R3 by 8, subtract from R3. 8R3 minus 9R2. 8R3 minus 9R2. Because we are going to make this 9 as 0. Then we will get our equivalent form. For that, 8R3 minus 9R2 multiply R3 by 8 will have 0, 72 minus 32 then 8 into 16 1 to 8 and there are 3 zeros. Then again now multiply R2 by 9, 9R2, 0, this is by 8, here R3 by 8 and R2 by 9. Now 0, 72, 45, here 9 into 185, 166500. You need not worry, you will be given a calculator while writing the exam. You can easily calculate these values. Then subtract, minus, minus, minus. This is 0, 0. Adding these two, minus 77. Now adding these two values, we will have 38500 minus. Subtracting these two values, we will get minus 38500. Okay, right here 0, 0, minus 77, minus 38,500. And then next move to bring this 8 as 0. If it make this one as 0 entry, this one become non-zero entry. So just to stop the process, 0, 8, 5, 18,500. There is no change in the first row, 1, 5,500. Now here, the last equivalent matrix is in equivalent form. The number of non-zero rows is 3. Okay. To solve, rank of A equal to, now rank of A is calculated by closing the last column. We have 3 non-zero rows, rank of A equal to 3. And rank of AB, in this also we have 3 non-zero rows, that is also 3. Therefore, rank of A equal to rank of AB equal to 3. Therefore, system is consistent. System is consistent and has unique solution. To find that unique solution, we should write the last equal matrix again in the matrix form. That will be first one is the coefficient matrix -1 3 1 -1 3 1 0 8 5 0 0 -77. The second one is variable matrix XYZ, and then the last one is the constant matrix 5500 18,500 and -38,500. Now equating this into linear equations, we can have the first equation will be -x plus 3y plus z equal to 5500. The second one 0x plus 8y plus 5z. So 8y plus 5z considered 8y plus 5z equal to 18,500. The third case 0x plus 0y both are omitted minus 77z equal to minus 38,500. Now dividing by minus 77, z equal to minus 38,500 divided by minus 77, which will be equal to, cancelling these two, we will have there are 535, 35, 5 times, that means 500. So z equal to 500, which implies 2 implies substituting in 2. Substitute in 2, we have 8y 5 into 500 2500 equal to 18,500. Now 8y equal to 18,500 minus 2,500, that is equal to 16,000, which implies y equal to 16,000 divided by 16,000 divided by 8, which is equal to 16,000 divided by 8. Therefore y equal to 2000, and substitute z equal to 500 and y equal to 2000 in equation 1. We have 1 implies minus x, 3 into y, 3 into y means 3 times 2000, that is 6000. Then third one z plus z, z means plus 500 equal to 5500. Totally we have 6500. Here we have 5500. Bring it to the right side, it will be minus x equal to 5500 minus 6500. So x is equal, minus x is equal to minus 1000, which implies x is equal to 1000. Therefore, the prices of the commodities are x is equal to 1000, y equal to. Next question, question number 8 in exercise 1.1, that is the last question. Given there are 3 amounts invested in bond, the total amount invested is 5,000, and then the income from the each bond is mentioned as the first bond 6%, second bond 7%, and third bond 8%. Calculating the interest, simple interest for the each bond, 6% of x, 7% of y and 8% of z totally yields the interest at 358. Then 6% of x means 6 by 100x, that means 6%. Here all are annually is given, therefore n is taken as 1. In this case, yes, simple interest is equal to PNR by 100. P means X, N is 1 year, rate is 6%, totally that is equal to 6% of X, that will be equal to 6 by 100X, 6 by 100 into X, that is written here. In the same case, 7% of Y, 7% of Y, then 7 by 100 into X, here also N equal to 1, and here 8% of Z, N is 1, then 8 by 100, the total interest value will be equal to 358. Now all are have 100 as denominator, then cross multiply it. Now here we have 6x plus 7y plus 8z equal to 35,800, or multiply by 100, you will get this equation. This is second equation. And the third case, given that the amount invested in the first two bonds will be equal to 70 more plus the third bond is given. For that, 6% of X plus 7% of Y will be equal to the 8% of Z, the value of 8% of Z plus 70. That is mentioned in the question itself. And then simplifying these by the above method, we will get 6x by 100 plus 7y by 100 minus 8z by 100 equal to 70. Multiply by 100, you will get another equation, third equation as 6x plus 7y minus 8z equal to 7000. We formed three different equations now. This is the system of three equations. We should solve by rank method. For that, write in matrix equation. To write matrix equation, first write the quotient matrix. The quotient of the first equation 1 1 1. So 1 1 1 taken here. The quotient of the second matrix 6 7 8. So 6 7 8 is taken. And the quotient of the third equation 6 7 minus 8, 6 7 minus 8. The second is always the variable matrix x y z, and the right side we have constant matrix. The first equation has constant 5000, the second equation we have constant 35,800, the third equation we have constant 7000. So this is the respective matrix equation. Now we should form a augmented matrix. This is in the form of Ax is equal to B. So augmented matrix AB equal to augmented matrix AB, that will be equal to 1 1 1 5000, second one 6 7 8 35,800. Therefore, the augmented matrix is AB 1 1 1 5000, 6 7 8 35,800, 6 7 minus 8 7000. Now we should reduce by using elementary transformation. Now to make this 6 as 0, multiply R1 by 6 and subtract. R3 tends to R3 minus 6 R1. In this case, we have R3 as 6 7 minus 8 7000, and 6 R1, multiply R1 by 6, 6 6 6 30,000. Subtract 0 1 minus 14 23,000. 0 1 minus 14 23,000. The second iteration, again here we have 6. So R2 tends to R2 minus, again multiply R1 by 6, 6 R1. That will be equal to R2 6 7 8 35,800. Then R1 multiply R1 by 6, 6 6 6 30,000. Subtracting, we have 0 1 2, here 5,800. Right in the second row, 0 1 2 5,800. There is no change in the first row. You can write as it is given in the question, 5,000. Now we should make this 1 as 0. Then we will get a equivalent form. Both entries are 1, so directly we can subtract it. R3 tends to, the new R3 formed by using the previous equivalent matrix R2, R3 and R2 by R3 tends to R3 minus R2. Just subtract these two. I am not choosing R1 here because these two entries are 0 while we subtract the remains the same. For that purpose I am choosing these two to bring this element as 0, and also this one is also 1. 1 minus 1 becomes 0. So R2, R3, new R3 formed here by using above R3 and R2 by subtracting R3 minus R2. So 0 minus 0, 0, 1 minus 1, 0, minus 14 minus 2, then minus 16, then 23,000 minus 5,800. 23,000 minus 5,800. We have 23 minus 28,000. You can write here R3 0, 1 minus 14, 23,000. And then R2 0, 1, 2, 5,800. Here we have minus 23,000. Sorry. Then now subtract minus 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 0, 0, minus 16 and minus 23,000 and minus 5,800. Then which implies totally we have minus 28,000. 28,800. We can have 28,800. Now minus 28,800. Therefore the last row, third row becomes 0, 0, minus 16 minus 28,800. And then our next priority to bring this one as 0. We can subtract R2 and R1. We can get 0, but in the same time if we make this one is 0, this become non-zero. So just to stop the process. So 0, 1, 2, 5,800. There is no change in the second row and there is no change in the first row also. 1, 1, 5,000. Here we have a final equivalent matrix. In this we have formed a equivalent form, and then this last equivalent matrix contains 3 non-zero rows, and rank of A is equal to, we have 3 non-zero rows, 3, and rank of AB is also equal to 3. Therefore rank of A equal to rank of AB equal to 3, equal to number of unknowns, equal to number of unknowns. Therefore system is consistent and has unique solution To find this unique solution, again we reform this equivalent matrix into matrix form again. The corresponding matrix form of the last equivalent matrix is coefficient matrix 1, 1, 1, 0, 1, 2, 0, 0, minus 16 into XYZ, which is equal to the constant matrix 5,000, 5,800 and minus 28,800, which implies there are 3 equations. The first one is x plus y plus z equal to 5,000. The second equation is 0x plus 1y, so 0 omitted, so 1y plus 2z equal to 5,800. The third equation is 0x plus 0y, so both x and y omitted, minus 16z equal to minus 28,800, which implies z equal to 28,800 divided by 16. Which is equal to 1,800. Divide by your calculator, which will be equal to 1,800. Now Z equal to 1800. Substitute Z in equation 2. This is equation 1. This is another one, equation 2. This is the third equation. From third equation we get Z equal to 1800. Substituting in second equation, y plus 2 into 1800, 3600 equal to 5800. Then subtracting y equal to 5800 minus 3600, which is equal to 5800 minus 3600, which is equal to 2200. So y equal to 2200. And x, substituting in 1 implies, substituting the values of y and z in 1, we have x plus y plus z equal to 5000 here. So x remains same, x plus then y plus z, adding the values of y and z, we have 2, 3, 4000, 4000, x plus 4000 equal to 5000. Equation 1 implies x plus y plus z to 5000. Substituting y and z, 1800, 2200, x plus these two implies 4000. So x plus 4000 equal to 5000, which implies x is equal to 1000. Therefore, the solution is x comma y comma z equal to, therefore the solution x y z equal to, or the amount invested in each bond. Therefore amount invested in each bond is 1000, 2200, 1800.